In fluids, you can expect 10 different types of questions on fluids at rest involving use of P is equals to P0 plus rho.g.h. 10 different types of questions on buoyant force. One type of question on the effect of temperature on density of fluid. 10 different types of questions on fluids in motion where you will need to use Bernoulli's equation and equation of continuity. 9 different types of questions on surface tension, 5 different types of questions on surface energy, and 5 different types of questions on viscosity. So let's quickly go through them all. Starting with fluids at rest, where it requires use of P is equals to P0 plus rho.g.h. In the first one, you might be asked to determine pressure at a depth h inside a fluid of density rho, given the atmospheric pressure P0 at its surface. Or you might be asked to determine the atmospheric pressure at a certain height, capital H, given atmospheric pressure P0 at the ground. In the second type of question, given a hydraulic lift with cross-sectional areas A1 and A2, you might be asked to determine some unknown using the fact that at the same height, pressures will be the same. Or, given a U-tube of uniform cross-section with two liquids of densities ρ1 and ρ2 and lengths L1 and L2, you might be asked to determine the difference in heights of the two surfaces. Or, given a circular tube of radius r and thin cross-section and containing two immiscible liquids of densities ρ1 and ρ2, with both liquids occupying certain section of the tube, you might be asked to determine the angle alpha when the two liquids are in equilibrium, with angle alpha being the angle made by the interface of the two liquids with the center. Or you might be given an open glass tube immersed in mercury in such a way that some length extends above the mercury bath. Now, if the open end of the tube is closed and sealed, and the tube raised vertically up by an additional length, you might be asked to determine the length of the air column above the mercury in the tube. Here you can assume that the air trapped inside the tube is an ideal gas. Now in the next question type, you might be given a U-tube or a container containing liquid that is set rotating at constant angular speed. And you will need to determine the variation in height of the liquid as you move radially outwards. Moving on, in the next question type, given one or more than one immiscible liquids in a container, you might be asked to determine the force exerted by the fluid on the wall. Okay, now in the next type of question, you might be tested on your understanding of how to calculate potential energy or change in potential energy of liquid. Here, remember that for an extended body, you use the height of the center of mass when determining potential energy. Moving on, in this question type, you might be asked to determine pressure as a function of radius r due to the liquid's own gravitational force. Interesting question. Think about it. And in the next question type, you will be asked to determine the shape of the liquid in the container that is accelerating horizontally. Or you might be asked to determine the pressure as a function of height in a container that is accelerating vertically upwards. Hope that gave you a good overview of different applications of P is equals to P0 plus rho.g.h. And to understand how to approach or solve each one of them, go to the question type section at JEE.com. Now let's talk about the questions involving buoyant force, whose magnitude is simply mass of displaced fluid times g, and direction is vertically upwards. And once again, here you can expect 10 different types of questions. So starting with the first one, here you might be asked to determine the apparent weight of an object submerged in the fluid. In the second one, for a floating object of density rho and volume v with a point mass on the top, you might be asked to determine the fraction of volume of the object that is submerged. Additionally, you might be asked to comment on what will happen to the level of the liquid in the container if the point mass slips and falls into the liquid. In the third one, you will be dealing with a hollow cylinder floating in liquid of density rho L, and the hollow container might be partially filled with some liquid. Read through the notes to understand the involved complexity in this scenario. In the fourth one, A cylinder might be floating in a container with two or more immiscible liquids, and here you might be tested on your understanding of the buoyant force, which simply is the vector sum of the pressure forces exerted by fluids on the object. Note that the top liquid in the setup shown exerts no net force on the container. In the next one, you are again tested on your understanding of the buoyant force and the fact that it is simply the vector sum of all the forces exerted by the fluid on the submerged object. In the sixth one, to make things interesting, you have a spring attached to the completely submerged object, and you will need to carefully write your force balance to determine the stretch in the spring. In the seventh one, you have a tall object that is floating in a liquid, and you will need to determine the torque exerted on it on account of the buoyant force when it is displaced by an angle theta from its vertical position. In the next one, we have an object submerged in a liquid which itself along with the container is accelerating upwards. Here, you will need to carefully write the Newton's second law to determine the unknown, say the tension in the string. In the ninth one, you will need to determine the acceleration with which a heavy object will sink in the liquid. In the last one, you have an interesting scenario where an object that seems to be completely submerged is actually exposed to the atmosphere at the bottom. So here, you should avoid writing the buoyant force as simply mass of the displaced fluid times g, but rather use your understanding that buoyant force is simply the vector sum of all forces exerted by the fluid on the object. So that concludes all the different applications of buoyant force that you can expect in your JEE Main and JEE Advanced exams, or NEET exams for that matter. But go through the detailed notes and practice questions in the question type section for developing problem solving skills. Moving on, in this question type, you will be dealing with questions involving effect of temperature on density of a fluid and the floating solid and the resulting change in fraction of volume submerged. With that, let's see 10 different types of questions you can expect in case of fluids in motion. So starting with the first one, here you will be given a stationary vertical vessel filled to the height h with a liquid of density rho and open to the atmosphere at the top, with a hole of cross-sectional area A at a depth h from its surface. And you might be asked to determine the rate of flow of water from the hole, or you might be asked to determine the depth of the hole h for which the range of the liquid coming out of the hole would be maximum. Or you might be asked to determine the time taken for the level in the vessel to drop by a certain height. In the next one, you might have a piston of mass M at top of liquid, and you might be asked to determine the flow rate in this scenario. In the following one, you will once again be asked to determine the flow rate, but here the container is moving upwards with an acceleration alpha. In the fourth one, here the container is free to move horizontally on a frictionless surface, and you might be asked to determine its acceleration when the height of the liquid above the hole is, say, h. In the next one, you will need to determine the equation of continuity to determine the desired flow rate. In the following one, you might be asked to determine the work done by pressure on a unit volume as liquid flows across a pipe of varying cross-sectional area and height. In the seventh one, you will be asked to determine the cross-section of the water flow by the time the water has descended a certain height h. In the eighth one, you might be asked to determine the pressure at a point in the smaller tube in the configuration shown here. In the next one, wherein we have a horizontal tube of varying cross-section, you might be asked to determine the unknown using Bernoulli's equation and equation of continuity. In the last one, we have a tube that is moving through liquid at a certain speed, and you might be asked to determine the speed of efflux as seen by a stationary observer. And that concludes the different types of questions asked on ideal fluids in motion. And we will now look at 9 different types of questions asked on surface tension, where you can use balance of forces to determine the unknown. So starting with the first one, here you will be asked to determine the unknown using the knowledge that excess pressure in air bubble is 4T by R. In the second one, you will be asked to determine the contact area of the bubble before it detaches from the bottom surface of the liquid bath. In the next one, you will be given a scenario wherein two bubbles of different radii are connected, and you might be asked which bubble will shrink and which one will get bigger. In the fourth one, involving a soap film on a frame, you will be asked to solve for the unknown using the knowledge that force exerted by film on account of surface tension is 2TL. In the next two question types, you will be asked to determine the height of rise of liquid in the capillary on account of surface tension. In the next question type, you will be dealing with surfaces with two radii of curvature, in which case excess pressure will be equal to T times 1 by R1 plus 1 by R2. Two additional ones in this category are A, where you will be asked to determine the radius of the resulting bubble when two bubbles coalesce or combine under isothermal conditions. In the other question type, you will be asked to determine the radius of curvature of common surface when two bubbles touch each other. With that, we will move on to question types on surface energy, wherein we will see four different types of questions. Number 1, wherein you might be asked to determine the change in surface energy when two air bubbles coalesce together. In the next one, you will be asked to determine change in surface energy when two or more liquid drops coalesce together or a liquid drop disintegrates into smaller liquid drops. In the next one, you might be asked to determine the energy required to enlarge a bubble from initial radius Ri to final radius Rf. In the last one, you might be asked to find the work done by surface tension as liquid rises in the capillary tube. Now, moving on to question types on viscosity, here you might be asked to determine viscous force between layers of a parallel flow, or you might be given a spherical body moving through air or liquid, where you will be asked to determine the terminal speed. Or you might be asked to comment on the nature of the flow through a pipe by determining the Reynolds number. Or you might be asked to determine the flow rate through a capillary using the Poiseuille's formula.